Hi, everyone. Thanks for joining. We're just giving a few more minutes for folks to join before we get started. We will be starting in approximately 1 minute. Thanks to those of you just joining. We'll be starting in about 30 seconds, just giving folks a chance to join. Okay, well, let's get started. Hi, everybody. Thanks for joining. Welcome to our webinar event. It is Understanding SBOMS, a practical guide to implementing NIST and CISA's software bill of materials requirements. The presentation will be delivered by Julie Peterson, our Senior Product Marketing Manager at SciCode. I'm John Jarbo, and we'll try to ensure that the event goes smoothly for everybody. I can be reached through the chat panel on your screen, and thank you again for joining us. A recording of this presentation will be shared after the event, in case you have to step out or if you want to share the information with others who couldn't make it today. Throughout the presentation, feel free to post any questions you may have into the questions panel, and we will wrap up with a Q&A session, and we hope to get to all the questions that are in there, but depending on how many come in, we may not have enough time. And with that, why don't we get started? Julie, I'll hand it over to you.
Great. Yeah, thank you everyone for joining us today to talk about SBOMS, everyone's favorite technology these days. I am Julie Peterson, and I am, as John said, a Senior Product Marketing Manager here at SciCode. I have worked in tech my whole career, and the last few years I've been working in the security space. I've worked for such notable employers as Mend, or formerly White Source Software, IBM, who you may have heard of, and IDC, among others. Our agenda for today is, first, we're going to start with some of the challenges we see about software supply chain security. Then we're going to do a dive into what is an SBOM. We're going to round it out with what are some of the limitations and gaps that we currently see with SBOMs, and then finally wrap it up with a Q&A session. So again, if you have any questions, feel free to enter them at any time, and we'll try to address them at the end. So without further ado, let's just jump into some of the challenges that we're seeing today. So, we've all seen the headlines. We know that software supply chain attacks are on the rise, right? SolarWinds and CISA, they're happening more frequently. They're happening with more intensity. And in fact, Gartner is saying that by 2025, nearly half of us will have experienced some kind of attack on our software supply chain. And I think evidenced by the fact that you're all here, we all know that it is really an issue that's growing, and we're trying to get our hands around it. Now, why is there such an increase in software supply chain attacks over the last couple of years? Well, I think the simple answer is that attackers are shifting their priorities from production applications that we've done a pretty decent job in locking down to the software supply chain itself. Now, the software supply chain is complex, it's deeply interconnected, and it's often, unfortunately, overlooked by many organizations. And attackers are using this oversight as a way to get in. And not only are they able to get in, but they're able to sort of sit undetected for longer periods of time. They're able to move laterally throughout the systems, and then they're able to scale their attacks and really target downstream customers, so they can get sort of a big bang for your buck, right? Attackers are just like the rest of us. They want value from their effort. But this is why we're seeing such an increase in software supply chain attacks. So Before I go too much further, I want to just make sure that we're kind of all on the same page on what I mean by a software supply chain. And I figured the best way to do that was to relate it to something that we all know pretty well, which is a traditional supply chain. And in this case, I picked a car manufacturer. Let's say it's a Ford F-150, right? We're building a truck. Well, with any supply chain, there's a number of components that you build in-house. So think like your engine, your drivetrain. There's also a number of components that you source from other companies, right? It might be your disc brakes, it might be an infotainment or some kind of circuit. But the whole point is that you don't control this. It's outside of your manufacturing environment. You're pulling it in and trusting that third party is going to give you a good product. Then you have the manufacturing infrastructure that puts everything together, and your workers who are making everything happen across the board. And this relates pretty nicely to software and how we develop software. So we have our custom code that we build in-house. We have dependencies in the form of open source components, third-party software, other things that we pull in, again, that we don't build or have direct control over. Then we have our DevOps tools and infrastructure that puts everything together, and of course, our developers who are the glue that makes everything happen. Now, with software supply chain attacks, we start looking into what are the things that, as a software development house, what don't we have control over? And it's these third-party dependencies that are really the subject of software bill of materials. The idea is that your customers trust you to develop securely. They also need to know, however, what is going into the other components that you're not necessarily creating in-house. And that's what a software bill of materials is focused on. So, why does this matter? Well, as we all know, modern application development relies heavily on these application code dependencies like open source libraries or third-party components. And in fact, we estimate that about 80 to 90% of all modern code bases are these dependencies that we don't have any control over. And downstream customers often don't know what are in these, and they want to know. And so an SBOM was developed to give greater transparency. And in fact, in May of last year, the White House released an executive order on improving the nation's cybersecurity, in which it defined the software supply chain as essential to national security and economic security. And so again, this is kind of a direct output of the SolarWinds attack. The federal government at the time sort of understood that they couldn't do it all themselves, and they needed a public-private sector partnership in order to lock down the software supply chain. And their overall goal is to increase transparency. So it's a word you'll hear over and over again today. So transparency is key here. And one of the key ways in which they're trying to do that is by mandating that a software bill of materials is required for each product. And one of the things that we see is that when the federal government mandates something, it ends up kind of trickling down into the rest of the market and becoming the de facto way of doing business. Now, why is this? Well, if you want to sell your software to the federal government, you need a software bill of materials. If you want to sell to a company that is selling to the federal government, you need to give them a software bill of materials. If you're selling to a company that's selling to a company, you get it, right? It's sort of this chain reaction, and that's how it ends up becoming the de facto standard. And so what we're seeing is that over the last year and a half, there's been a lot of talk and a lot of chatter about, what do you need? What are the minimum requirements? What even is this whole thing? And so that's what we're going to talk about more today. So let's start with what a software bill of materials is. Kind of at its simplest form, an SBOM is a formal record that contains a list of inventory that details the supply chain relationships. So it's telling you what all of the components are in your software and then how they are related to each other. I like to sort of think of it as an SBOM being like a list of ingredients for your software, right? So we have, we're all pretty familiar with the list of ingredients that come on food packaging. Here we have a delightful lemon ginger scone from King Arthur Baking. If you're in the Northeast like I am, you're probably familiar with this brand. But they do these great scones, and on it they have an ingredient list. So if you're concerned about what you're eating, you can look at it and understand exactly what's in it, and you can make an assessment about whether it's good for you to eat. So SBOMs are sort of like that, right? They're enumerating all the components that are in your product, and they're useful for a variety of different people, right? So developers or the manufacturers of software can use an SBOM to identify what's in their software and ensure that all of the components are up to date. When a new 0-day has been announced or disclosed, they can use an SBOM to respond quickly to new vulnerabilities that they might have. Buyers can use SBOMs, and this is really one of the big use cases we see, to evaluate the risk of using that software. So they might use it to see what vulnerabilities are potentially in that software, or what licenses. Perhaps they don't want any restrictive licenses if they're going to be using your software as part of their solution. So again, gives them transparency. And then finally, ultimately, the users can quickly determine whether they're at risk when something new is released. And again, transparency is key. One of the other big components for SBOMs is that they need to be machine readable. So automation is key, and we'll dive into that a little bit deeper in a few minutes. So if you think of an SBOM like a list of ingredients for your software, and we take those delightful lemon ginger scones as an example, we can break it down into parts, your atomic parts like flour, sugar, baking soda, and then compound parts, crystallized ginger, lemon drops, right? These are made of other things. So lemon drops is not something you can harvest from a field or pick from a tree. It's something that's manufactured and created. And so it has multiple pieces that come into making it. When you're looking at your SBOM, you then have actually a person or an entity that is putting it all together. So in this case, it's King Arthur Baking. They're taking all of their ingredients, they're combining them, using their magic and creating these delightful lemon ginger scones. They're then selling it to their local grocery store. We'll call it Groceries R Us. And the grocery store, in turn, is selling it to their downstream consumers who are very excited to get these yummy and delicious lemon ginger scones. So the supply chain relationship in this case looks a little bit like this. So you have your parts and compound parts coming together, they're being assembled, they're being distributed to Groceries R Us, and then ultimately reaching the downstream consumer. Now, in many cases, you might have a grocery store who say they're really concerned about transparency and their customers' health, and so they want to know everything that's in the ingredients, right? So that's why we have the list of ingredients in the first place. But say they're really concerned about allergen information. They don't want to kill off any of their customers accidentally. And oh, by the way, this person down here, we'll call them Robin. Robin has a severe milk allergy, and so this store, being concerned about their customers, wants greater transparency, goes back to King Arthur Baking and says, hey, look, we need to also know what's in your compound parts. And so King Arthur Baking will break down their compound parts into these parts, and guess what? Lo and behold, lemon drops contain milk. And so Robin down here can make an assessment of, like, hey, look, I don't want to go into anaphylaxis and end up in the hospital or maybe dead, so therefore I can't drink this. I can't eat this scone, no matter how delightful, because it has something that I can't tolerate, that I'm severely allergic to. So if you think about this as your software supply chain, you've got the parts that you create yourself, you've got your compound parts, which might be open source libraries, you're assembling them, you're selling them, your solution to a downstream person who ultimately is giving it to their customers. And so therefore, understanding exactly what's in it at a very granular level is important for everybody involved. And this is how your SBOM is like a list of ingredients for your software. So now the National Telecommunications and Information Administration, under the US Department of Commerce, released a report working in collaboration with CISA and NIST on the minimum elements for, I think the title says it all. These are the minimum elements. So think of these as a starting point. This is a new, emerging, and sort of maturing market. And so this is the baseline of where we're starting. It's not supposed to be an exhaustive list, but it's a good starting point for everyone who is looking to either generate and create an SBOM or looking to use SBOM data to make assessment about purchases. And so the NTIA broke down into sort of three main buckets, including data fields, automation support, and then having practices and processes in place. So data fields gives you uniform structure that allows you to present information in a very easy and consistent manner so that they're easy to understand and easy to use. Automation is key here because we're dealing with lines and lines of code and lots of components. It can be quite complex to understand the supply chain relationship between various components. And then again, having set practices in place about how an SBOM is requested, created, and used is also really important. And we're going to look at each one of these individually in a little bit more detail. So the first thing is that you need data fields that contain baseline information about each component. It should also give you information about how that component is maintained. And you need a consistent uniform structure so that all your components are given the same information. At the same time, even though you need this consistency, you also need it to be flexible, understanding that as SBOMs mature, more information might be needed. So again, it seems a little paradoxical, but you need consistency and flexibility. So what do some of the data fields look like? Here on the right is a header of a typical SBOM. This happens to be an SPDX, and it kind of gives you some of the information like of what it would typically look like. And so if you look, it gives a supplier name. So for example, it might be Apache, it might be the supplier, the open source project Apache. A component name might be a specific Spark library. Then you would have like the version of the component, other identifiers. So if you need like to look it up in a database or other things that would be included here. And then you need the dependency relationship. So how does this component relate to other parts of your SBOM? And then you need a of the SBOM, so you need to capture who that is. The SISA framework suggests that the author of SBOM data actually is a build service, and so it's done automatically, and that would be captured. So it would say exactly what created the SBOM, and then a timestamp, of course, is important. Now, this is actually, this picture here shows you a specific component. In this case, it's sugar. Right, so the package name is sugar. It gives you the version of it. The supplier is, Domino Sugar. And then here it's really interesting. It tells you the relationship. So it's saying that King Arthur Baking Lemon Ginger Scones contains this specific ingredient. So that is where we see the supply chain relationship. It's also really interesting to know that there's some information that we don't know, and this we'll talk about a little bit later, but it's listed here that there's some information that we just don't know about this component. So that's typically what the baseline data fields look like in an SBOM. It is very human readable and easy to look at. So you can kind of look at one and see exactly what you have in the components. The second sort of main area that the NTIA identified as a minimum element for an SBOM is automation support. So it's really important that SBOMs are automatically generated. I think it's pretty clear that it's with all of the components that we use that go into building our software these days, that it's a process that really we couldn't manage manually. And automating it is really important, not only for accuracy, but also so that you can automate the output, but then when you want to input the data and ingest it, you can do that automatically. When it comes to automation, you need to across all of your organization boundaries. So if you have multiple teams working on one project, you need a solution that can grab information from all of the teams that they use to create something that's really comprehensible. And then finally, machine readable. It's really important that your SBOM is machine readable, right? The point is not to generate one, but to use the data and actually ingest it. And there are 3 recognized formats right now. They are the Software Package Data Exchange, or SPDX, Cyclone DX, and Software Identification Tags. Now, they all have slightly different flavors to them. SPDX is out of the Linux Foundation. It is the only one that is ISO certified. So if that's something that's of concern to you, that's probably the version you would use. Cyclone DX is created by the OWASP Foundation and is considered a lightweight SBOM. Coming out of OWASP, it's very much security focused, so data integrity is a big key here. And so again, Cyclone DX has specific use cases. SWID is primarily used for people who are concerned about licensing. So if licensing is your big go-to, maybe you're doing an M&A activity and you want to see what the licenses are that you're buying, this might be the version that you use. And then the final sort of bucket that the NTIA defined was that organizations need to have practices and processes in place around their SBOMs. And the interesting thing is that they gave a list of things that you need to talk about and define, but they didn't actually define them for you. So again, they're not defining the practices, the best practices, they're asking you to have them, to define them yourself. And so the first one is frequency, right? You need to identify and be transparent about how often your SBOM is created and updated. Are you doing it on every build? You know, if you're thinking about agile development environments where they're deploying code or daily, lift, take. Again, depth is important. You know, I think at the very least, you want to have all primary and hopefully transitive dependencies. This image here on the right is actually an NPM dependency tree, right? You all know that transitive dependencies are really hard to manage and handle that. This looks at a dependency tree for the NPM project. You can see how interconnected it is. And in fact, this isn't even the whole dependency tree. I had to kind of zoom in to it just so you could even read it. But again, depth of SBOMs can be quite complex. And so that's something that you want to define and be transparent about. And then again, there are going to be simply some things that we don't know. And you need to be able to identify the known unknowns. So think about like a legacy system where maybe you don't have access to the application code and you just don't know what's in it. Well, it is your response when you have either incomplete or completely missing information on, and transparency by identifying what it is that you just don't know. Distribution and that you need to define. So how are you going to make your customers know that you have this information available? How are you going to always on a specific website, or there's a specific where they can information? Is it going to be contained in the release notes? So again, this is something that you need to define and make well known so that your customers can access this great information that you're creating. Access control, again, is something else that you need to consider. So, you know, are you going to make it available to everyone out there? Is it publicly available, or is it only for your customers? And so you need to define who has access, and then also specify where this is defined. So is it part of your contract when you're negotiating a sale? Is it part of your licensing agreement? Again, these practices and processes are things that you need to define. And then finally, NTIA understands that as a maturing technology, we're going to have mistakes as we all start in this, and supply chain data is still evolving. We know that mistakes happen. We don't want the perfect to be the enemy of the good, and so you need a way to, you know, notify if a mistake has been made, a way to notify your customers that, hey, you know, something was missing or the wrong version was reported. And so these are some of the practices and processes that you required for the minimum elements for an SBOM. Now, again, these are the minimum elements, and I think if you start thinking about it, there's really quite a number of gaps that are missing. Again, this is a starting point. It's not perfection. And so in the next section, I want to talk a little bit about what I see as some of the limitations and gaps and how you could potentially plug them going forward so that you have an SBOM that really does actually help you reduce your supply chain risk. Now, I think it's really interesting in the NTIA report, they are very open about the fact that an SBOM is not a panacea. It is not going to stop every attack. And in fact, a number of the high profile attacks that we've seen recently would not have been prevented by having an SBOM, because the tools and systems that were used to manage and build the software actually were what was targeted. I'm looking at you, SolarWinds. So, right, we know that those tools were entry points, and having an SBOM would not have prevented a vulnerability in a build server, for example. So this brings me to the first SBOM challenge, and that is that SBOMs only look at application code dependencies. Now, again, I've said this a couple of times, and I want to be really clear. If you think of a dependency as being something that you don't build yourself and that you have no direct control over, obviously open source components and third-party software fall into that nicely, right? And that is what SBOMs are focused on. They're looking at these code dependencies. Now, these code dependencies are a huge piece and they're really important. I don't want to downplay that, but it's not the only thing that you need to worry about when looking at your software supply chain. There are a lot of other dependencies that come into play. So, for example, you can look at dev tools. These are dependencies that you use, and you use quite a lot of them, and they have been the entry point for various different exploits. So SolarWinds used a TeamCity server to infiltrate the supply chain, as a nation state attack. I shouldn't say SolarWinds, but Russia basically used a dev tool to get in. GitLab, I think over the summer, had a vulnerability in it that allowed for remote control execution. Okay, either one of these, just not a great place. You want to make sure that you are aware of these dependencies and that you're locking them down if they're not a way in. Now, dev tools have plugins that are also pieces of software. And you can think of these plugins as things that you buy in a marketplace that enhance the performance of a tool or expand the capabilities of a tool. And these third-party plugins are pieces of software that somebody else has built that could themselves have vulnerabilities. And in fact, in July, early July, Jenkins disclosed that they had 29 different plugins that had a total of 34 security vulnerabilities. And again, this is a type of dependency that you don't have control over, that you don't create, but could be a serious risk. If you look at build modules like GitHub Actions, again, this is software that is created by a third party that could have its own vulnerabilities. Here we have the Try and Web IDE, which was created by Red Hat. And again, wouldn't it be great if you knew exactly what was in this? It's impacting your software and could be an attack vector. And so wouldn't it be great if the SBOM was also identifying this type of dependency? Build modules themselves are created just like any other software in that they can pull in their own dependencies, and those dependencies can have their own vulnerabilities. And then IAC templates, which is used to partition, runtime environments, can run their own scripts and pull in other libraries that have their own vulnerabilities again here. So we believe that in the future, SBOMs should expand their definition of what a dependency is to take into account all of the dependencies across the entire pipeline, right? So not only dependencies in code, yes, it's important, and that's what SBOMs are focused on now, but also all of the dependencies in your pipeline, which can help you by taking this bigger picture, better align your security program with the risk that's really happening out there in today's world. The second challenge that we see right now with SBOMs is that they are just basically a list of components. They don't actually contain any vulnerability information. And we believe that for SBOMs to be really useful, that they need to contain vulnerability and prioritization data. It could be information like the CVE itself and the data that's included with that, perhaps the CVSS score or reachability to help you prioritize, right? So a lot of solutions out there have algorithms that can determine like, okay, here you've got you're using a library that has its own dependencies, right? These transitive dependencies, and you get to a point where it is calling a function that has a vulnerability versus like the middle and the bottom path where, yes, there's a vulnerable function in there, but you're not actually executing in a runtime, so you can safely deprioritize that. So that would be really great information to have in an SBOM. Like, yes, okay, we know that there is a vulnerable function here, but we're not executing it at runtime, and so then you can safely deprioritize it. So again, having vulnerability and prioritization data as part of your SBOM can really help more accurately assess your risk. The third challenge that we have here is that SBOMs are not inherently secure. As I pointed out earlier, they're very much human readable. And in the case of like a dependency confusion attack where a malicious actor is uploading a new package with malicious code in it, they could easily alter an SBOM to show the version that with the malicious code is right, because they're generally not secure. And so the solution to this is to make sure that the source of your SBOM data is verified, that it hasn't been tampered with. So that involves signing each SBOM, and that way users can determine whether your SBOM is legitimate and accurate and hasn't been altered, and then matches with the actual application. The fourth challenge we see with SBOMs is that SBOMs are so focused on application code that they just don't have visibility into your pipeline configuration or security posture. Now, most development teams look something like this. You have various teams using different tooling. Even if you're an organization that says, okay, fine, we're going to standardize on one set of tooling and make sure everything is properly configured, what happens when you have M&A activity and you bring in a company that has its own set of tooling? Even if you plan on standardizing them on your current set of tooling, doing that change and porting everybody over is going to take time. And in the meantime, you're ending up with a lot of different and complex tooling. And SBOMs can't tell you whether that tooling has been properly configured. So most of the times these tools are implemented by engineering, not with security in mind, but with sort of speed of development in mind. And so, how many times have we heard default passwords being in a way that an attacker got in? And you don't have to look too far to actually see real examples of this in the wild. If you look, the state of New York a couple of years ago had, actually this was just last summer, had a server that was exposed to the internet that allowed anybody to create an account and give themselves any level of permissions if they wanted to. So you could go in, create yourself an account, and then sort of get into any system you wanted to. And the bottom line here is that you don't need to exploit a vulnerability if you can just get in through a simple misconfiguration. And we see this happening all the time. I think Nissan was another example where they had a lot of customer data and marketing stuff exposed because they didn't configure servers appropriately. So the solution to that is to get a software that can understand your security posture so that it can harden these pipelines against attack. So if you have an SBOM that can identify, that what all the tools are in place that interact with your application as it's being built, and then you can understand whether it has best place, least protection settings and tool configuration. And wouldn't it be great as a software provider if you could say, hey, look, not only am I giving you full transparency of what's in my software itself, but I'm also giving you full transparency that all of the tools and things that interacted with my application actually have been done in a secure way. So I think that could really be an added bonus for SBOMs as we see them today. And then I think the last challenge that I'm going to talk about today, and certainly there are other ones, but the last one I'm going to talk about today is that SBOMs really are just a snapshot in time. And with the amount that software is, with the speed that software is being developed and the frequency, it's something SBOMs need to be dynamically generated automatically, right? So I think, again, automation here is key. So you need an SBOM that, when it's dynamically generated, that it's automatically accurate. That all your directed transitive dependencies have been identified, as well as pipeline tools and configurations. You're giving vulnerability and remediation data so that we can then use an SBOM to help make your software more secure. And then, ideally, with this dynamically generated SBOM, you would be able to suck in your cloud-based application stack and understand what's happening in runtime so that you can then scan and understand any vulnerabilities that might be part of your cloud environments. That, again, you can identify it and you can lock down your software supply chain from code to cloud. So again, these are just some of the things that we think are really good and will help you improve your software supply chain security. So I think the big takeaway from today is that generally you need a more complete approach, that having an SBOM as it is today is a great starting point. But in order to really lock down and stop the attacks where we see them happening, you need something that's going to look at the whole software lifecycle holistically and lock everything down, including your tools and infrastructure. So when you're looking for an SBOM, I think what we suggest is that you look for SBOM that have these enhanced capabilities that we talked about today. So first of all, start with complete visibility. Something that can understand your entire SDLC and pipelines is going to give you a better output in terms of SBOMs than something that's just looking at application code. You want, again, SBOM that can look at all dependencies, not just application code, and one that gives you vulnerability and remediation environment. You can pinpoint the locations within your code and your deployment environments on where these vulnerabilities are happening. The SBOM itself needs better security so that it's not been tampered with and changed by somebody who's looking to do harm. And then finally, an SBOM that can understand that your pipeline and improve that your pipeline is secured, I think is something that would provide a huge advantage. So just to recap our session today, we all know that software supply chains are a large and growing problem, and you wouldn't be here if you believed otherwise. Security, as we all know, is not something that you can, it's not an endpoint that you can reach and be done with once and for all. So I think understanding that it's an ongoing process and using SBOMs as one of the tools in your tool chest is important. Again, SBOMs are a great first step towards transparency and should require data fields, machine readable, and having well-defined processes in place regarding distribution, consumption, depth, and other things that we talked about. That being said, though, it's a great first step. It's not a perfect solution, and that in the future, we really believe that SBOM should identify dependencies across the entire SDLC. And again, dependencies are those things that you don't create or control. They should contain vulnerability and remediation data. They should be securely generated and distributed. And then they should be able to understand how your tooling impacts your application. And then finally, always be updated and accurate. So before I move on into the Q&A, I would like to just talk a little bit about who SciCode is. We are a complete software supply chain security solution, and we have 8 different tools that help you secure your SDLC. We break them into 2 main categories. The first one is those that find vulnerabilities, so scanners like SAST, SCA, container scanning, and IAC. And then we have tools that help you harden your pipeline. So we have pipeline security and governance, code tampering, hard-coded secrets, and code leakage. All of these tools sit on top of a graph database that we call the knowledge graph, and that correlates and connects data across your entire SDLC so that it gives you a complete picture and helps you prioritize risk and really helps you lock down your software supply chain. So that is it for my formal presentation today. I'm going to pull John Jarboe back in, and we're going to try to go through some questions. If you have any questions, this is a great time to put them into the question box right now. John, what do you got? Anything at the moment? Okay, I don't seem to have John. I don't know if I lost him on the line.
Sorry about that. Can you hear me now?
Oh, I can hear you now. Were you muted?
Yeah, I was like double muted somehow, but sorry about that. So yes,
no
we do have
worries.
some questions before we get into the full questions that require more detailed answers. We did have a question about whether we can share the presentation with attendees, and just as a reminder, everybody who registered for this event is going to get a recording of the presentation. So you can look for that in your inbox over the next day or two. And there was another question about kind of, what tools are out there that can create these SBOMs. And I know I'll add on to that I know we talked about a few different types of SBOMs as well, different levels of information that can be in them. If you can elaborate on that a little bit as well.
Sure. So, traditional software composition analysis tools are generally what are generating SBOMs today. And again, very useful, but they are focused only on application code. And so what you need to look for is a software composition analysis tool that actually looks at your entire pipeline. And SciCode offers one of these. We're calling it Next Gen SCA or Pipeline Composition Analysis. So it's doing for your software application what SCA does for software application. PCA or pipeline composition analysis is doing for the entire pipeline. And so that, this pipeline composition analysis is natively built to look at all of the dependencies, not just in your code, but that, get pulled in as your software moves from, code to production. And so I think, if you look for tools like that expand upon what's being scanned and where, you'll be able to create this kind of next gen SBOM or this improved SBOM version 2.0. John, did you have anything to add there?
Well, I mean, I think you covered most of the big pieces, right? I mean, there are tools. Most of the tools that exist are looking at what's inside the application, and we're starting to see some of these newer tools like Cycode that are looking not only at the application, but the environment and the process through which the application was built to help find kind of those indirect ways to attack the application itself, right? If you can
Yeah,
influence
I
the
mean,
way the
that's
application's built, then you can influence the application.
right. Yeah, I mean, that's where we're seeing the attacks coming in anyway, right? It's the part of the process that's been overlooked. And, you know, if you go through the attacks over the last couple of years, you know, more than half of them would not have been prevented by, you know, the traditional tools that we have out there, which is why they're still happening. So yeah, look for these next gen tools that can handle the pipeline.
Awesome. Yeah, okay, and we have another question here. It says, given the OMB memo from September and the current limitations that we were just discussing about, you know, these SBOM tools, do you have any recommendations for organizations to help them get started taking advantage of some of these benefits that SBOMs can provide and start moving toward compliance with the requirements that are coming out of the government?
Yeah, so I guess just to make sure I understand the question. So are there any tools out there for demos or
Well, I think the question is more around just, you know, some recommended steps for moving toward compliance with these
yeah.
new requirements that are coming out of the government. You know,
Yeah, I mean, I think
of the existing tools, are those simply adopting some of the existing tools? Are they going to be sufficient, or is there more that organizations need to do in addition to getting those tools to make sure that all the bases are covered?
yeah. So I think you know, again, this is we're all kind of learning as we go, and so there are existing tools that will get you started. I think, you know, if you're looking for a net new tool, look for something that um, is flexible and can handle some of these more advanced capabilities, you know, like security, like looking at your dev tools. Certainly, the NTIA has a number of reports that kind of identify. But again, a lot of this is being defined as we go. So I think, you know, the point is put a stake in the ground and get a program up and running. You know, it seems easy, but I think, you know, it's always going to be more complex than we always hope. So put a stake in the ground and then start moving forward from there.
Yeah, that makes sense. I mean, it's a big problem and it's not very well defined at the moment. So certainly
Right.
you have to start somewhere, start there, start solidifying around that, and then you can add in pieces as you either discover gaps or requirements that weren't clear initially.
Yeah. Yeah. But I think, you know, being able to generate one, being able to communicate to your customers that you have them, and having, you know, those processes in place are going to be a good start. You know, there's some best practices to start. And again, you know, the government is giving a lot of leeway at the moment on how you define and create it, and so, you know, use that flexibility to help define your own specific needs. You know, it's not a rigid process at the moment, and you know, use that to your advantage.
Yeah, and I imagine that there's probably, well, I'm sure there are organizations out there that also need to work, you know, kind of approach it from a cultural level of just building a culture of transparency, where there may be there may be organizations that have a little more of a, you know, a culture of secrecy, and it'll take some time to get their mind around to being comfortable with being transparent like that. So I guess that's kind of another aspect to it. Cool. So we have another question here. You know, are there best practices around how the SBOMs are created or used or shared, right? I mean, we have, in some cases, you can have 20, 30, 40, you know, who knows, um, however many applications you're building, plus the subcomponents of those may have their own SBOMs. What are kind of the best practices around creating them
Yeah,
and using them?
that's a truly excellent question. Yeah, so I mean, I think this is where automation is a big factor and really important. So again, it's all well and good to be able to generate an SBOM, and you're going to need to do it if you want to sell to the federal government, et cetera, et cetera. But really, the whole point is not having one, but actually ingesting that information. And so I think, you need a tool that can pull in the data from all of these various SBOMs and can do analytics on it and really understand and build a full picture of your risk, right? So if you see again, a vulnerability in your code base might not be, 5-alarm fire, whereas if it's actually been deployed to a cloud environment and is in production, is. And so you need a tool that can ingest the data, analyze it, and correlate it together to make these connections. Without the connections, you won't have a full picture of your risk. And so again, I think automation is really, really important here.
Yeah, and I think that's an interesting aspect you just mentioned there too, right? I mean, a lot of people think about SBOM tools as something that you do during the build process, but being able to leverage that information of what's in the application with knowledge of how it's being used and where it's deployed really amplifies the value that you get out of that SBOM. So it's not, most tools, individual tools are not, while they may give you an SBOM, they aren't necessarily going to tell you how that code is being used. And so that's another aspect that organizations really need to, kind of build on their own to understand how the components that they're using are being, that they're building into their applications are being used on the runtime side once it's been deployed.
Mm-hmm. Yeah.
Nice. Okay, there's another question here since we're kind of talking, well, this is more about SciCode specifically, I guess. There's a question, is it possible to integrate SciCode with existing tooling? Things like Jenkins or Bamboo, GitHub Actions.
Yes. Yes. In fact, that's what what we were built to do. We have sort of pre-existing connectors out of the box that help you easily integrate and get all of this information, so that you understand things like your security, your governance. Make sure that your best practices are being followed. But yes, we do that.
Yeah, I think one thing that's, just to build on that a little bit, one thing that's a little different about SciCode, I think, is that we're not just looking for security problems, right? I mean, one of the fundamental pieces of SciCode is understanding what your SDLC looks like, right? Which tools are you using? How are they being used? How are they configured? Even before we start looking for any sort of security problems, it's important to know what you're doing and what you're trying to accomplish. And SciCode is really built to kind of find all of those tools and give you visibility into what's happening in the development process, even before we start trying to find, security related insights into what's happening. So that's another area that is a little bit different from how other security type tools work, is we're not only looking for security problems, we're also looking at what are you doing and what are you using and where are they being used and who's using them and all of that sort of thing to really give that visibility. And then kind of a downstream effect of that is, because we have all of this visibility into what's happening, we can do a lot to help identify security issues, regardless of whether it's something really isolated, like a particular configuration problem, or if it's something that spans the entire development process, like how a misconfigured SCM tool may impact what's happening in the deployment process.
Yeah, I think just one last point to reiterate, you don't need a vulnerability if misconfiguration can get in the door. And misconfigurations happen all the time.
Yeah, absolutely. Cool. And I think we have time for just one more question. Unfortunately, it seems to be a bit of a big one, but hopefully we can squeeze something in here. It says the things you describe sound good, but how do you fit them into today's current standards, which seem pretty limited? I'm not sure if that's talking about the kind of the SBOM, formatting standards that you discussed earlier, or if that's more general around just improving the software supply chain security.
Yeah, do you want to take a stab at answering that, John, or?
I guess, let's see. Well, I guess
That
I
doesn't
kind of,
get in.
yeah, what I was just talking about with Psycho kind of addresses some of this already, actually. One of the biggest issues I think with improving, I'll look at it from a more general standpoint, improving the security of your applications is really about visibility, right? It's not just looking at the current standards and the current tools and identifying very specific kind of siloed information, if you will, like looking for dependencies within your application is interesting, but looking at it from a broader perspective of not only what's in the application, but what's in the process that builds the application. And, might there be weaknesses in any of that, is really important, because what we're seeing is that a lot of attackers are focusing more on the supply chain and more on the development process than on the applications themselves nowadays. And those are areas that are commonly overlooked, probably not coincidentally, or it's probably not coincidental that attackers are now targeting those things. Probably it's because they are not as well secured as the applications themselves are. So I think probably one of the easiest things you can do, to start trying to improve your security is really getting that visibility, not only into what's inside your application, but what's in the development process of the application, taking advantage of some of these supply chain security type solutions that that help you see not only what's in the application, but how the application is being used and how it's being deployed and where it's being deployed, so that if a problem is found, you can really track that across the whole SDLC to figure out, where do I need to change things to avoid this problem or to fix this problem.
Right. Visibility and context. I think those are key.
Cool. Well, I think that is all that we have time for today. Thank you for attending, everybody, and thank you for the great questions you submitted. Like I said, we will be sharing a recording of this presentation with all the folks who registered for the event, and feel free to share. If there are any questions or any thoughts that come in, you can always feel free to reach out to us. And with that, I will wrap up. Thank you and have a good day, everybody.
Thank you.